Okay, this one, I like to just do it out twice. And I said or equivalent techniques because people who took AP Calculus usually learned a little shortcut, which I don't care too much for, but I will make reference to it for the benefit of those who do know it. Okay, so I just look for what looks like a good U and V. And again, what my eye is seeing a component that I don't mind taking the derivative, wish to d by dt this piece, and another piece that I don't mind integrating on that side. And so by doing so, I'm shifting the derivative from one piece to the other. That's the effect. The strategic technique of switching the derivative from one place to the other. Okay? And so unlike when I do U substitution, I don't care about making the pieces match up. The pieces are not going to match up the same way, but these pieces are going to completely take up the entirety of the original function. Okay, does that make sense? So as opposed to, like, if I'm going to do U, maybe I have like t squared plus t over here, and I can have cosine of t squared plus t. That's all good as long as I have somewhere 2t plus 1 dt. Alright, and then the whole thing's going to end up being like cosine of u and then du. See, this is what U substitution looks like, where the pieces, for example, the square root can stay and this cosine can stay. That kind of structure remains after you get rid of after you do the U substitution. Okay, but then when you're doing UV, this is integration by parts, these pieces have to all be represented exactly. There's no leftover square roots or pieces of functions floating around to keep track of. Everything has to just break down as a product of U and a product of dV. Okay, so it's a different technique. All right, so we go ahead and we use uv minus integral v du by whatever mechanism you memorize it. Okay, let's put it together. U times v minus integral v du. Okay, then we figure out, well, what is this guy doing? 2 can come out here. This is the piece we're now worried about. All right, that one I'm going to think about in red, and then I'm going to go back and put it all together. So I'm going to say u dv again, and then v is e to the t. Got my dt over there. Du is dt. So that piece is going to be u v minus integral v du, and so it's going to look like this. And that is all going to be in parentheses, so this is all going to be like this, copy paste, and of course you do the same thing by hand. Okay, I'm doing it as a copy paste so you see this piece just gets carried down. And then we have a plus c. Now if you prefer to clean that up, you're more than welcome to clean that up. It would be cool if you did, but I won't take any points off if you don't. Alright, but that looks cleaner to do it that way. Okay, so just if you happen to be one of those people who did this trick, let's see, you would have something like you'd put the t squared over here and the e to the t, and you'd keep taking derivatives until you get down to 0, and you'd keep taking integrals until I don't know when. I guess because there's a 0 on the other side you can stop. But now you can see this structure, this t squared, let's do it here, t squared e to the t, and then you're going to have to put a minus sign on these guys, 2t e to the t, and then this distributes, you're going to get 2 e to the t, so these signs are going to alternate. Okay, and personally this is why I don't like this. It looks, it doesn't really stimulate understanding, but if it's something you've already done in your past and you're comfortable with it, then that's totally fine. But if you haven't done it before, don't try to learn it, because you're only going to do a couple problems in this class and it's not worth the time to memorize it. Okay? So one way or the other, you're going to end up with this kind of answer. Okay?